Good day, everyone. Welcome to our CodeGuru session. My name is Daniela, and I'm a product manager for Amazon CodeGuru. Today with me is Beruz Nubakt, senior software engineer from Atlassian. Together, we'll explore how you can find your most expensive line of code with Amazon CodeGuru. Amazon CodeGuru is a developer tool powered by machine learning that provides intelligent recommendations for improving code quality and identifying your application's most expensive line of code. It consists of two services, CodeGuru Reviewer and CodeGuru Profiler. CodeGuru Reviewer uses machine learning to identify critical issues and hard-to-find bugs during application development to improve your code. CodeGuru Profiler helps you find an application's most expensive lines of code along with specific visualizations and recommendations on how to improve code to save money. You can build Amazon CodeGuru into your existing workflow along with other developer tools, where you can experience built-in code reviews with actionable recommendations, detect and optimize the expensive lines of code, and easily identify performance and cost improvements in the production environment. Amazon CodeGuru has so far focused on improving the durability and availability of your applications by providing coding best practice recommendations and detecting hard-to-find bugs such as race conditions and deadlocks. However, customers told us that security is their top priority and would like to be able to catch any security issues as early as possible in the software cycle. Now we're announcing a new wave of detectors to improve security of your code and provide recommendations for best practices, which is a priority for CIOs and CSOs. At launch, we will identify security risks from the top 10 OWASP categories, such as a weak hash, security best practices for AWS APIs, and common Java crypto libraries. Our security detectors use machine learning to analyze data flow from source to sink and across multiple functions to detect hard-to-find security vulnerabilities. You can go to the CodeGuru console and trigger a full repository analysis and upload your source and build artifacts to get security recommendations. The security recommendations are provided at no incremental cost to the customer, and also they support Java 8 through Java 11. There are several categories of issues that can be detected by security detectors. First, AWS API security best practices. With them, you can check API security for AWS, EC2, and KMS. Number two, Java crypto library best practices. You can check if JavaX crypto cipher is initialized and called correctly. Number three, secure web applications. With this detector, you can check web app-related security issues such as LDAP injections. Next, sensitive information leak. You can check if there's any leakage of personal or sensitive information. And finally, AWS security best practices, such as AWS crypto recommendations. Those best practices developed for our internal use are now available for external customers. Here's an example to show how CodeGuru Reviewer Security Detector checks basic AWS credentials for AWS KMS API to ensure that hard-coded credentials are not passed in. For example, when the security detector finds that hard-coded secret credentials have flown into the basic AWS credential constructor, it provides the recommendation for the customer to set AWS credentials with environment variables. This is a more secure way to supply AWS credentials to the AWS SDK for Java. Now let's look at a demo of how security detectors work. Navigate to the CodeGuru console and you will find there three sections: Dashboard, Reviewer, and Profiler. We'll focus on Reviewer and go to code reviews. We see two tabs: pull request for PR-based code reviews and repo analysis for full repo analysis. We'll initiate full repo analysis. There's two options: traditional code review versus code review with security recommendations. Select the second option. Give a repo name and click Create the S3 bucket, so it will create the S3 bucket, a repo, and associate with CodeGuru. And now we're waiting for the S3 bucket creation. S3 bucket was created, and now you can directly upload the source code and build artifacts from local machine or S3. Here, we first will select the source code from your local machine. As you can see, there is a separate upload for source code and separate one for its build artifact, the jar file. Now let's give a name for our code review scan. Once we give a name, we'll trigger code review. The code review is in pending state. We'll fast forward the video by 4 minutes and see it completed. Now you can see that there's 10 recommendations generated. If you go back again, CodeGuru uses the same bucket for that region and lets you create a new repo. Alternatively, you can use the existing repo too to trigger code review. Now let's review a few of the recommendations. The first recommendation suggests using the temporary security credentials using IAM roles, which are more secure than keys. CodeGuru also provides a link to the best practices for using access keys so you can get required info. This security recommendations label associated indicating severity. It points out that hard-coded credentials are used. Now let's look at source code line 50. You can see the function calls is passing credentials. And here you can see that hard-coded credentials are present in plain text in code, which is a high risk. Now let's scroll down to this recommendation pointing out potential resource leak. We'll go to line 158 to confirm the source leak. Looking at line 158, beginning of next function, there is no close statement for file output stream in the previous function. The next recommendation shows a security label and points out the input received by a function is not sanitized. The code shows that the function is receiving a request object from which a cookie and path are derived. As pointed out, this is unsanitized file path and can lead to path traversal attack. Check out this reference link provided that explains the path traversal attack in the OWASP site. More detailed recommendations are covered in our blogs, and this brings us to the end of this demo. Today, we're also pleased to announce the launch of Python support, in addition to the existing Java support. Python is a widely used language for various use cases. Python's growth in data analysis and machine learning areas is driven by its rich frameworks and libraries. We've mined thousands of pages of Python documentation and millions of code artifacts to identify hard-to-find coding issues. Customers now can onboard CodeGuru Reviewer and start analyzing their Python code by using pull requests and full repository analysis. Our Python support covers 7 detection categories: from Python standard libraries to AWS Python API best practices. Let's look at the details of those categories on the following slide. There are 7 Python recommendation categories, and these are highly valuable for customers during code reviews. For example, CodeGuru Reviewer offers pagination APIs recommendations for various AWS services so that customers can verify all results are returned when using the AWS APIs. There are other highly valid recommendation categories on the list, including Python standard library, data structures and control flow, error handling, resource leaks, and so on. For example, if you are a data engineer, the data structures and control flow category can help you ensure the efficient and correct handling of data structures and control flow in Python standard libraries. If you're a data scientist, resource leaks category can help you ensure that external files are closed properly so that there is no resource leaks to slow down or even crash your system. Here's an example to show how CodeGuru Reviewer provides recommendations for AWS Python API best practices. In the code snippet, the customer is copying items from one DynamoDB table to another using the scan and put item APIs. However, DynamoDB paginates the result from scan operations. A single scan only returns a result so that it fits within the 1 MB size limit. If that result contains a last evaluated key element, then it is recommended to construct a new scan request. If there is not a last evaluated key in the result, then there are no more items to be retrieved. Therefore, CodeGuru Reviewer identified missing pagination in this scenario and recommends to fix the code by handling the paginated results of the scan operation appropriately. Lastly, for Reviewer, we're pleased to announce a simplified onboarding experience for GitHub Enterprise repositories. Customers can now provide GitHub Enterprise server endpoints and all configurations needed for VPC and private networks in a single step and get explicit feedback on whether the endpoints are reachable and the connection is successful. Reviewer supports both AWS cloud-hosted and on-prem GHE repositories. Amazon CodeGuru Profiler has so far focused on CPU profiling to help you improve CPU utilization and latency of your applications. I have Behrooz, Senior Software Engineer from Atlassian, who will talk about how Atlassian leverages CodeGuru Profiler. Behrooz, the mic is yours.
Thank you, Daniela. So I am Behrooz from Atlassian. I am from a team which we call Jira Cloud Performance, managed by Matthew Ponsford and a teammate of mine, Arnana Swami. I'm here to present what we have been able to achieve integrating Amazon CodeGuru in our production environments. So Atlassian has a mission to be able to unleash the potential in every team so that they could do their work in an efficient and optimal way. For that, we actually have products such as Confluence, Jira, Trello, Bitbucket, and so forth. All these products actually have a lot of teams working on them, and all of these products are actually running on AWS environments. So we are operating a large production environment on AWS. When an incident occurs, it can be sometimes hard to diagnose the root cause of the problem because there are so many changing factors at runtime, and we need to be able to sieve through many facts to be able to understand the actual root causes. That's why we usually try to focus on techniques that would help us improve diagnosis. One of the techniques is called runtime profiling, and it actually has a good amount of history in JVM. So previously in Atlassian, we actually had some tooling around profiling. We had some tools that were able to capture profiling data from our application at runtime, but there were kind of limitations around the tools that we had. For example, we had interventions necessary from other teams to be able to support us, such as SRE or elevated access to be able to run some of the commands to do the profiling. Also, we had this difficulty of running ad hoc profiling was not sufficient, because when we get to know something is not running as expected, there is a time that we need to act fast, and if that time passes, then it means that we have passed the moment that was good to be able to capture those profiling data. So that is why, I mean, we had these limitations, and it started to motivate us to look at continuous profiling as a way that continuously captured the profile data and to be able to use them to visualize and do analysis. Our solution was kind of based on the previous scripts that we had. So we had a schedule that run them automatically and based on the schedule, and then we uploaded data to storage, which is S3 by AWS, and then we deployed Amazon Glue and Amazon Athena to be able to run queries and extract information and visualize them. So this was pretty much what we had in place, and at the same time, we received the announcement from Amazon CodeGuru Profiler, and it was quite an interesting coincidence because there was a lot of overlap with what we have built so far, and it was also very well crafted as a product. So we tried to experiment with the tool in a short amount of time, and the experiment was quite successful, and it looked promising. So we decided to switch adopting AWS CodeGuru rather than continuing to build our solution. So AWS CodeGuru actually comes in two modes. One is the agent mode, and the other one is the internal JVM profiler. We decided to go with the JVM internal profiler because we thought we were having this requirement that we needed to be able to control the feature at runtime, which was something that was easier when compared to using Java agents. So, and basically it was a library, and then we just used the library, and now it's running in all our productions, which is quite nice. So next I'll just run through a few examples that we have been able to use this nice tool in our systems. One of them is one of the classical Java examples in terms of concurrency and synchronization. So at the beginning, we started to explore AWS CodeGuru for understanding how the code is and if it can find interesting things to fix and improve the performance. Interestingly enough, we came across a very traditional example, which is based on Java's enum map. Enum map is an abstraction in Java that allows the developer to hold a map of enum types to any arbitrary value. But the interesting part is that internally, enum map uses synchronized collections and Java's synchronized approach, which is known to have a lot of thread contention, especially if your application is using high multi-threading. So on this figure, you are actually seeing some blue bars and red bars. The red bars are the runnable part of each stack frame, and the blue bars are the block state. So as you can see, there is a lot of block state in our systems, and this was not good. Although, I mean, it's not that noticeable, but still you do not want to lose the CPU utilization. So as soon as we fixed this, all of these actually came to red. Yeah, we stopped using enum map, but that was fine. We just used a concurrent hash map, which is still a better concurrency approach. And this was a very nice and traditional go through is that AWS CodeGuru also comes with a different type of view, which is called hotspot view. Basically, it's like an icicle view of the top stack frames ordered from top to bottom. On the left figure, you could see that one of the top ones that we saw in our systems was object hashcode. Object hashcode is a native and system call in Java, and is supposed to be very fast. So it got us very curious of why this is happening. After some investigation, we found out that there was an object as part of the request lifecycle that we could have cached, and it was being stored on a thread map. And that map, because it was on a thread which was interleaved among many threads during the request lifecycle, it was causing a lot of thread contention because of the map functionality, which depends on object hash code for keys on the map. So as soon as we actually deployed and implemented a caching mechanism for that object type, we saw that amount of hotspot view reduced from 16% to 5%. This was nice because on the other side, we could also see that from AWS CodeGuru, we get some insights on how much cost reduction we get. And this is only on a single environment. We have so many environments. So 60% of cost reduction was very favorable for us. So yeah, we have been quite through the CPU journey, but the performance engineering journey continues for us. And now the next stop for us is memory. There are so many interesting questions that we are interested to be able to solve for. For example, a very classic example in JVM is the heap usage. There are times that incidents happen, and part of that incident data is that we see that there is a sudden spike in the heap usage. We would like to understand what are the object counts that have the highest number, or which objects are the largest ones on the heap. And also, in addition, sometimes it's very, very insightful to be able to understand which part of the code base is generating which object types. Because then we could understand that there could be different code bases that actually generate same time of objects. And this could open up so many interesting opportunities to improve the performance and memory utilization of the system. So yeah, this is pretty much our current story, and thank you very much for having us in this session. Back to you, Daniela.
Thank you, Baruz. Many of our customers told us that they were also having challenges troubleshooting memory-related issues on production environments. We're pleased to announce memory profiling support for Java and other JVM languages. Now with CodeGuru Profiler, you can do a full heap summary, which will show you memory utilization per object type, whether your own domain classes or those owned by libraries or the JDK. With Heap Summary, you can discover what is eating up your application's memory so that you can fix the code allocating expensive objects. The Heap Summary view also shows a time series graph of your memory objects so that you can detect any abnormal utilization, such as memory leaks or an impending out-of-memory problem. You should consider profiling memory with CodeGuru in two situations. First, when you're troubleshooting memory leaks, you can use the time series to identify constantly growing objects so that you can resolve out-of-memory errors and application crashes. Second, you can use the Heap Summary dashboard to optimize memory footprint of your application so that you can reduce the cost of your compute infrastructure. Heap Summary helps you identify objects with high memory footprint so that you can focus your analysis on the right part of the code. Now let's look at a quick demo of how memory profiling works. Let's start from the top of the user journey. When you go to your profiling group, you can now see a summary page which shows you high-level information about your profiling group. When we spoke to our customers, they told us that they want to be able to more easily find which profiler insights to focus on. And this is why we built the summary page. The summary page shows you high-level metrics related to your profile along with relevant visualizations. It also shows you the top anomalies and performance recommendations. The high-level metrics help you more easily decide which visualizations to focus on. And each recommendation shows you the CPU impact to help you focus on what matters. Now let's look at the heap usage. You can see that the total heap available to the JVM is 505 megabytes, and that your average heap usage is 43%. However, your peak heap usage is 75%, which is a little high. Let's find out what's happening. Let's go to the heap summary. What you see here is a time series graph of the objects on your heap. The red line shows you the total heap available, and the blue line shows you the total used space. And you can also see time series of selected objects. Below that, you can see all the object types on the heap. They're arranged by average usage, or you can also arrange them by average number of objects, or code types such as built-in, primitive, or third-party. You can visualize any of the objects on the time series graph. Now let's focus on the top 3 objects. You can see that at 4:20 p.m. your heap usage started growing, and this is primarily caused by 2 objects: the Java util link hash map entry and Java lang UUID. If this upward trend continues, you might be running into an out-of-memory situation soon. So when you're troubleshooting memory problems related to your application, you want to focus on those 2 objects in your source code. You can also go from the heap summary into other visualizations such as CPU or latency, or you can decide where to go next by going back to the summary page. This completes our demo. As announced earlier, CodeGuru Reviewer now supports applications written in Python, which helps you fix difficult-to-find bugs. We're pleased to announce that CodeGuru Profiler now also supports applications written in Python. CodeGuru run it continuously on production with minimal overhead. Python Profiler supports applications running on AWS EC2, Amazon ECS, Amazon EKS, Fargate, as well as AWS Lambda. In addition to AWS compute infrastructure, you can run Python Profiler on premises as well. Python Profiler supports applications written in Python from version 3.6 to 3.9, and for AWS Lambda it supports versions 3.6 to 3.8, with upcoming support for 3.9 once AWS Lambda supports it. Similar to the Java Profiler, the Python Profiler provides visualizations which show how much walk log time for your application spends in each code path. You have the same 3 standard visualizations: Overview, Hotspots, and Focus View. Overview shows you the key entry points into your application so that you can identify the slowest code paths. Hotspots show you the methods that take the longest time. And with Focus View, you can identify all the callers and callees related to a method of interest. So, to quickly recap, today we're really excited to announce 5 new capabilities for CodeGuru. Reviewer now provides security detectors and a new GitHub Enterprise sign-up funnel. With Profiler, you can now profile memory. And both Reviewer and Profiler now support Python. You have now seen what are the new capabilities that CodeGuru gives you to improve the code quality and identify your application's most expensive lines of code. To help you get started, we're offering a 90-day free trial. So you can try Amazon CodeGuru for 90 days at no cost in supported AWS regions. You will have access to the full feature set, except for the full repository analysis, during the free trial. For full repository analysis that includes security recommendations, We offer 30,000 lines of code per month for free. Start improving your code quality today. Thank you, and please complete the session survey.